In this video we're going to take a look at a couple of examples dealing with the angles in a polygon. And the first one that we're going to look at is this one where I want to find the measure of angle 2, which is an an interior angle, and the measure of angle 1, which is an exterior angle of the octagon. Now notice the problem tells us that this is a regular octagon. So we have to think back to what does it mean to be regular. Well, it means that all the sides are congruent and all the angles are congruent in the octagon in this case. What I like to do is I'd like to start with the measure of angle 1. And the reason I want to do that is because I remember that if I were to take all of the exterior angles of this octagon, there would be 8 of them, and I would add them all together, it would come out to be 360 degrees. Well, being all the interior angles are congruent, so this one, this one, this one, so on and so forth, that's going to tell us that all the exterior angles are going to be congruent to each other as well. If I were to create this exterior angle, this one would be congruent to the measure of angle, or be congruent to angle 1. That tells me then is I can take that 360, which is the sum of all of them, divide it by 8, and it's going to give me the measure of just one of those exterior angles, which is going to come out to be 45 degrees. I've now figured out the measure of angle 1. Well, then to figure out the measure of angle 2, I'm going to look at these two angles together. So really I'm going to find the measure of the angle that's right next to angle 1, the adjacent angle, because the measure of that one is going to be equal to the measure of angle 2. I know the two that I have marked in blue have a sum of 180 degrees. Then all I need to do is take 180 degrees, I need to subtract out the measure of the exterior angle, which was 45 degrees, and I'm going to have my answer, which is going to be 135 degrees. That's the measure of angle 2, which is my interior angle. I already figured out the measure of angle 1, the exterior angle. I have them both completed. Now, my next one is a little bit different, no picture to start. I have a little word problem. It says find the number of sides and the number of angles of a regular polygon if the measure of one interior angle is 150 degrees. Now I'm going to look at this problem two different ways, and you can kind of pick which method you like. I'm a person that really likes pictures, so what I'm going to do is I'm going to try to draw a picture of this polygon. Some of you are going, well, Mr. Root, how are you going to draw this polygon when you have no idea how many sides it has? Very good point. There's my polygon. I'm just saying it has a certain number of sides that we can see, and then this little dot 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 part out here, that's telling you that, well, there might be some more sides. But what I do know is, just like the last one, I have a regular polygon, which tells me that every single angle in this polygon is going to be 150 degrees. I'm going to look at the exterior angle then. I went out there. Well, I know that this interior angle and the exterior angle are going to have to add up to be 180 degrees. They're supplementary. Therefore, I'm going to subtract that interior angle's measure from 180 degrees, which is going to give me 30 degrees. This exterior angle has a measure of 30 degrees. And now I think back to the theorem that tells me if I add up all the exterior angles, it's going to equal 360 degrees. So I'm going to take 360 degrees, I'm going to divide it by 30 degrees, it's the measure of just one of them, and that should tell me how many exterior angles I have, which in this case is going to come out to be 12. Now if it has 12 exterior angles, that's going to mean that it's going to have 12 interior angles, and that also means that it has 12 sides. So I'm going to have 12 sides and 12 angles for this regular polygon that has one interior angle having a measure of 150 degrees. That's one way to look at it. Like I said, that's me being my picture person. Now the other way is to look at more of an equation standpoint. So it tells us the measure of just one of those interior angles is 150 degrees. So what I'm going to think back to is the interior angle sum theorem, which tells me the sum of the interior angles is equal to 180 degrees times the number of sides minus 2. Well, if I wanted to find the measure of just one of those interior angles, all I need to do then is divide everything by however many sides there are. Now, if I divide one side by But that's going to give me, excuse me, I should fix this a little bit. Here was the sum. Now if I want the measure of just one interior angle, so why don't I'm going to change a little bit. I'm going to go measure of just one interior angle. Then, like I said, we can take this. Here's the sum of all of them. If I want the measure of just one, I got to divide by however many I have, which is n. And then I can solve my equation. So I'm going to take this second one that I've just created. I haven't created it. I just manipulated things a little bit. And I'm going to fill in what I know. I know the measure of just one interior angle. That's 150 degrees. The problem gave that to me. Well, now equals 180 times, I don't know how many sides it has. I don't know how many angles it has, so I'm just going to leave that as n. And now I have an equation that I could solve. I'm going to look at this in terms of being a proportion, and then I can cross multiply. So this, 150n, is going to have to equal, multiply this way, 180, and I'm going to distribute right away, so I'm going to have 180n minus 360. Solve my equation. What I would do is I'd get rid of the 180n. Now I'm left with negative 30n equal to negative 360. If I divide both sides by negative 30, I find out that n equals 12, which is, again, the number of sides and the number of angles of this polygon. So take your pick on which approach you like. If you like kind of the picture approach, go ahead and do it that way. If you're more of a algebraic person and you'd rather set up equations and solve them, then go with this one. Start right there and work your way down until you get to the end. And then that's going to conclude my example portion of angles of a polygon.